Hi everybody, this is Mr. Roche. We are working on our air hockey game and let's see. Right now we have a puck that bounces. I've been working on mine. I got a St. Mark's logo. I'm very excited. And I have it bouncing over here, but it's not bouncing over here. Okay. And I want to get that done so everybody has that and just see what to do next so we can get the rest of the game going, okay? Let's see. Okay, so first off, let's kind of review what we have here. Okay, we have a class puck, okay? And what we're doing is we have variables for the diameter of the puck, its X and Y location, the speed of it. We put some variables for color, which we actually don't need right now. Because we're using images and things like that. We created a friction factor to allow for it to slow down, which we're going to put into use. We've created a reference to the table, so we can get data from the table about sizes and such, so we can run the puck. We have a file name to get the puck, which I'm using Peter Puck right here. Have a whole bunch of other things which I've used before, and I have I'm using a Java image to get image. Okay, so that's the data that I'm holding here. The puck, the constructor for it, takes the size, and it gets a reference to the table that the puck is on. They're going to be put on. These variables we store, see size and t get stored into class variables. And then let me get rid of this stuff because we don't need it. Then we do some stuff to figure out. I'm giving it a speed that I can change. I mean, really, when it first starts out, it should be 0. But right now we're kind of testing it, so we're just kind of having it run at 30 pixels, like a frame, basically. It doesn't change by Y, but I could change that. I find an X-log based on the table width and the puck distance, and a Y-log, which just the idea is it centers the puck at the center of the table. And then we work to open up the puck file image. Okay, so that's a try catch, which we talked about. We try to open up the file, and then we try to read the file into an image that we can use later on. Okay, draw puck is super easy because we're drawing images. If you're going to draw a puck, otherwise you have to draw circles, which we could do. And then we've done some more complicated stuff. Right now we have something to deal with friction. Okay, when we move the puck. And then we have a larger routine called check for bounces. Okay, and the first test for this was to determine here if the puck is moving to the left. Okay, and we have a test for that. And what we did was we checked to see if the table Y was correct. Okay, and then we found out whether there was. We're looking for like whether the puck would hit on the table this spot, because this one should bounce differently than in here. If you get in here, the puck should go into the goal, and if it gets here, we're going to have it just bounce here, because that's the way air hockey tables kind of work. And we can color this black or something. But and then we need to do the same thing over here. So we look and check and see if it comes under one of two sectors. So if it's here or here, we are on the table either here or here. Okay, and that's how that works. And if that's so, then we look to see if let me see. Then we look to see if the X-log has gone beyond this. Okay, and if so, then we push the puck back into the screen over here, into this area, and we flip the speed so it bounces off. Okay, and then otherwise, if we get to this place, means the puck is going into the goal, and we just have to check and see if it's gone too far, like over here. So if it's past 0, we put the puck back on the ice, basically, and then flip the speed. And so what we're trying to do is we're trying to write the opposite of this one, okay? So what we're looking for is, like, if the puck's moving left, we're going to do this stuff, okay? Otherwise, the puck's moving right, okay? We're going to do the other thing, okay? Basically, between this point and this point, they're the same on the y-axis. This point and this point also the same axis. So these regions y-wise are the same as the regions over here. The only difference between this line and this line is where it comes on the x-axis. So for our first check inside this thing, in this first if clause, we're going to say if, right? Oh, actually, we want to do this. If speed equals 0, do this. End speed 0. I want to do this as an else, I think, because I don't want to like have the speed change and then have to go do this again. It ends up in a weird situation. So I'm going to go like this and say basically else. Okay. And then I'm going to do this if speed is 0. So let me clean this up. I'm going to say here like this, or say else if speed x is greater than 0, right? What's called x speed? It's moving right. Then oh, I think I have to do this. Let me see. Else. Let me see. Okay. I think I need to do this to fix this error here. I think you need to do this. Okay. Because what we're looking for is if speed is greater than 0, then all of this is true. And then here we want like an else if here like this. Else if speed is less than 0, then what we're going to do is we're going to basically do the same idea of this thing. So what I'm going to do is I'm going to go like this, and I'm going to check basically the y locations to see if puck is going into the goal or hitting the side walls. Okay, so basically on this side it's the same problem. The puck can either go here or here, and we've already worked out a good test for that. So this is what I want here. So basically, if these things are true, then what we're going to do is look at the x value. Okay, so we'll go in here and look for x. And if this is going to look like, it's got to be, since it's going this way, y is becoming, or x is becoming greater and greater and greater, right? So this is sort of a backwards thing. So x look has to be greater than my table dot get with minus my table goal width. And if that's true, then this is going to equal this. Oh, yeah, I think that's right. Okay. So then this is going to equal this. And the speed is going to equal -1. Okay. Otherwise, okay. Then otherwise we're in the goal. Okay. And we just kind of wrote it like this. We could say if x log is greater than my table dot get width, because it's the back of the net, then the x log is going to equal my table get width and x speed is going to equal that times -1. Okay, and I think I had all the parentheses. Let's see what happens. Okay, so he bounces there. Oh, he doesn't bounce. Okay. So that's not good. But let's try him. I think I got an issue because there's an extra space here, or extra curly brace. So if it's greater than 0, then we want to check for its location. If its location is in the blue area, is not in the goal, we figure out this, and then we set the goal width, the x location of the puck. Okay, and I think you also have to account for the puck width. Puck D. Okay. There you go. There you go. Okay. Okay. So let's give this a whirl. I'm gonna have to stop if it doesn't work, and we'll come back in another video. Uh-oh.